Let's go. Okay. Hmm. Twitch. Cool. What about the people on my channel? Okay, we're good. We're good now. All right, so let's solve this question. Search in rotated sorted array. You are given an array of the n, which was originally sorted in ascending order. Okay, given an array of like n, which was originally sorted. Now rotated. So, for example, one of the big profile space can be so you can start as 3, 4, 5, 6, 7, 1, 2. So rotate it 4 times, and then this was rotated 6 times. Okay. Given the rotated sorted array norms and an integer targets, return the index of targets. Okay. Within -1 if it's closed, right? You may assume it's some duplicates are constrained to has to work. And so definitely we're gonna have to use binary search to solve this. And be more clear what seems constraint. Okay. Okay, let's try to find it out. So for example, let's look at the examples that we have here. Target is equals to 1. So I'll put 4 because 0, 1, 2, 3, 4, right? 5. Okay. And then okay. So basically, so we need to so search algorithm. Sure. The other thing we need to do, obviously, that you need to have your left and right corners, mid and other stuff. But I try to see that there should be a more efficient one. I think I did something similar to this before. So we can first essentially check if the list is rotated. So check if this how would we do that? That is essentially doing the condition that it's in ascending order, right? So that means if it's in ascending order and it has not been rotated, then definitely the first element should be lesser than the last element, right? So we could say if if node 0 is greater than -1, then it's rotated, right? If it's not rotated, so it's something I would have to do So you split between left and right. If it's not rotated, then um, perform normal binary search. If it is rotated, then I remember there was also another trick where it was like we need to check the point at the middle if it's less than or equals to if the point in the middle is, for example, the point in the middle, so what is this? This is how many? Six, right? So, three, right? So index three, zero, one, two, three. So the point in the middle is less than, the point in the middle is less than or equals to the starting element, then we are in the sorted part. If it's not, then we are in the not sorted, we're in the rotated part essentially. So, so if um, m is less than or equals to zero, we rotated. No, we're in the sorted part. Yeah, yes, part. But if not, yeah, send me, and then we need to check, okay, where's targets? Because we have a target, right? So, so for example, if targets is then less than m, right? Then we, search right, targets. Um, we're down and search the other side. Search the right part, the other way. And then if targets is equals to nums, just return if nums. That's essentially what the logic will be like for that. Um, okay, so let's try this logic out first to see if there's any misconception before we even start coding. Um, so for example, obviously left to right, left to be here, right to be here. Um, is 3 greater than this? Yes, it is. So that means it's rotated. So that means we're going to go into this use case. So we'll now check, okay, nums m, which is going to be so 0, 1, 2, 3. So 6 is 6 less than or equals to this. Yes. Okay. So we are currently in the ascending part or the organized part. But the target that we're looking for is 1, right? So is 1 less than or equals to, is 1 less than, what do you call it? Is 1 less than 6? No, right? So we're gonna go to the right part. So that means our left will now be n plus 1 and our right to be, you know, the length of the list, which is that, right? Yeah, so yeah. And just to clarify, right, when I believe it's all one, yes. Okay, good. All right, so yeah, using that is not gonna affect. Okay, cool. So that means we could just search there and we'll find it essentially. Um, and then perform binary search of that. Okay, cool. And in this scenario, it's not rotated because this is less than that, right? So we just perform the mod BST on that. Or we could, yeah. Okay, let's see. Let's go. Let me check this other one up there. YouTube. Well, okay. It's like that's not how the directory in YouTube looks. Oh yeah, Juggle, we need to promos today. That is true. When you use, I can't even check the values or not. Oh, there's one watching, so no, I don't. Oh, hi. I can't even check the values or not. Like same feed. I wish there was a way I could what you call it? I wish there was a way I could see my YouTube chat too as well. That'd be really nice. Um, that's nice. Thank you for at least watching. Appreciate it, man. How you doing? Actually, I should switch to my YouTube. Give me 1 second. Since at least there's somebody there. I need to figure out. There's probably some software um to see both chats. Um, I need to figure that out. How you doing, Onik 4RT? I don't know how to pronounce your name. All right. Okay, let's get started then. Okay, so obviously the basics for binary search. I'm just starting. I'm just starting. Zero. This one. Start in the end. Then while to assign the res of the next one, just in case we can find anything. So default return res. Something between. Then I think we need to first check. Do we first check if it's rotated or not? Or so okay, let me do this. If nums this nums 0 is greater than nums 1, okay. What information is that going to do for us? I don't know. It doesn't really help right now. Probably will, maybe later. You know, too as well. Okay, let's go. So this while um and do and so yeah, so the targets. Yeah, what do you call it? I mean, it is the targets equals as um, LF target is greater than nums. Oh, I see. Okay, that's where the um so if so it's rotated, it's gonna be so this um take So this is here. Um, so if we're in the rotated list, then remember to check it if those um, is less than or equals to zero. Zero. Um, and those elements less than or equals to zero, then we are in the rotated linear, we are in the ascending part. Okay. So so in the ascending part, then we can then check if it's a lot of this target greater than um, okay, so if target is then greater than we guarantee ascending part to it. Mm. Or we're in the sorted but not ascending. Okay. Right. Trying to visualize it because I'm looking for an exception somewhere where if you have been 4, 5, 6. Oh, but you're gonna need tab 3, you know what I mean? So the target is greater than those. That we're gonna have to search with the right part of here, right? So that means left is gonna be this one. Yeah, that's basically what it is. Left is gonna be this one. You know, right to remain the same. And ever it's less than um correct. Yeah, so one is um, one, yeah. I feel like I'm overcomplicating things. Okay, Okay, and that's what the iteration should happen because at this point we've been essentially figured out. Okay, so we in this other part then. Yeah, so we don't even need to do that then. If we're in this other part, okay, we still kind of need to look for a target, right? Yeah. I'm trying to visualize what I'm doing. I don't know why I'm not complicating stuff. Mm. Okay, yes, we're in the rotated list for sure. And then if numbers n, so for example, if 6 is here, right, and it's less than or equals to that, then we are in this ordered product that. I'm trying to look for a scenario where it's not 6, because 6 is kind of like the end of the list, so that does, give it away. But like, so for example, where it's like 1, 2, 3, 4, so 1, 2, 3, 4, and then we rotate that, it's like um 3, 4, 2, 1, 2, right? So it's 3, 4, 1, 2. The middle is gonna be what's 2, right? So 1, 2, yeah. Okay. So that means, and then when I check in, okay, yes, obviously when you rotate the list, that's fine. And when I check, okay, if numbers m, so if 1 is less than or equals to 3, yes, we write in this separate part, okay? Or not. Oh, so if yes, we're not actually, yeah. Yeah, my bad. So we're not in this separate parts. And if we're not in the sorted parts, then, but the thing is, why does the sorting matter though? Oh, it kind of matters because the direction where target to be, right? Okay. So if we're not in this other class, okay, we then need to check, okay, the targets, is it, if target is, where do you go? So if target is greater than or equals to nums m, so if target is, this our target is what? This our target is 2. If target is, how many people watching me? Jesus Christ. Nothing else is, which is fine. Um, if target is now greater than greater than nums in this case is 1, right? It is. I mean, you're not in the sorted path, right? So then this technically that should be that. Yeah. Okay. So that does make sense. Yeah. Actually. But let's say our target was 4, right? Wait, wait. Because 1, right? So in the case of 1, there's nothing smaller than 1. Well, I thought it was 4. 4 is greater than that, but no, because not necessarily. Ah, why is this tripping me up? In 1 second, let me start it over. Okay, so you know the story. Do I like editing football videos too? From time to time, I had the phase where I was editing football videos, but it wasn't anything crazy. It was just like, I was just doing it because I wanted to get better at like editing skills. And I used to have a TikTok. I still have a TikTok, but this is my TikTok. This is one of them. Um, this was a basketball edit I did. Um, this football edit somewhat. You can probably find it somewhere. I don't know. Yeah, I do a lot of stuff. I'll just put it in the chats. Yeah. Okay. Um, whole beans. All right. Let's continue. So obviously resident as well. So we then need to check, okay. You know what, in theory it sounds simple. So for example, essentially if it's rotated, right, we need to get context of where we are and then move. Right? So for example, the best way to check if it's rotated is if 0 is greater than minus 1. That means it is rotated. So if it is rotated, what does that mean? It means, okay, now we need to find our targets, right? So thank you. Thank you. We need to find our target, right? So if we need to find where the midpoint is, actually, wait, no, because let me just try something. Okay. If targets, right? Let's say we're looking for 5, right? That's greater than target. Actually, so let's check if it's in ascending order. So let's check where we're at. So let's say if, um, it's greater than. So this means that if this is greater than this, we are guaranteed that we are in a part that is sorted, right? That everything behind it is lesser than it. Okay, that makes more sense. So that everything behind it is lesser than it, right? So everything behind M is lesser than it, right? So that means if our target is less than m, that means it has to be between 0 and right before m, right? So that means left has to be, so that would be 0, yeah, and then right, then uh, so that's guaranteed. So if targets is greater than m, what does that mean? So if our target is one second. But it is so for example in this case where it's 1, right? That disproves the claim because 1 is smaller than 6, but it's not between that, right? It's actually in the opposite. So I guess opposite matters if it's rotated. Let's just go with this for now. Okay. And then this, and then this, and this. I'm just going off intuition. Because we need no logic here right now. Else, it's just because I've been thinking too much. Else, no, not else, because you can have other targets is equals to equals to. Uh, Say this is equals to this. Right. Then after this, we can then do while is less than equals to the R. And area where M, we calculate M again. So let's just copy this. Okay, nice. No, target is greater than those zones. And so then if it's not rotated, then you just perform normal binary search where we could just put this up here, subtraction. Um, So M is already there. So then let's say, wow, R, copy that here. Um, so what's up, hands up? How you doing? Okay, basically this then. Let me see this is gonna work. Let me try run it. This is a lot of code, but let me just see this go. How to start freelancing? I don't know. I would just say, um, I guess start with a portfolio, build enough projects so that, people actually see what you can provide service for. Which would probably be like, well, 4 to 5 good projects that are not really about the same thing, have different spheres, and then post about it on like social media, LinkedIn, Twitter. And then once you feel confident enough to like a point where like you've gotten personal contacts with people that you're working, then you can go to like Upwork and that could be like, where you like showcase your work and earn money on a bigger scale, you know. But let me check this out. Yeah. So let me try to run with this. So 3, 4, 5, 2. Okay. You're welcome, man. So we're gonna first check if is this rotated. So num 0 is 3, num 7 is 2. Yes, it is rotated. So we're gonna go into here, right? If num's M, so this is 1, 2, 3, 4, 5, 6. So 6 divided by 2 is 3. Which is gonna be this. Oh, 2.5 since we want to. Actually, because it's what left plus right, right? Yeah. So I'm not gonna lie, doing the calculation wrong. Yes, it's gonna be 0 plus 5, which is gonna be 5, right? So 5 and then so that's 2.5, so 2. So it's gonna be here. Yeah, right. So this is gonna be the middle here. So wait. Oh yeah, that does make sense. Right? Okay. Uh-huh. Yeah, so it's gonna be and so this is moving point here exactly. So if num zero is not already done there, num zero is greater than or equals to num zero, it is. So if target is less than or equals to num, target is 1. Is it less than that? Yes. So we're gonna go from here down. Okay, that's good. Good to know. Uh-huh. And yeah, and we just leave this case. Exactly. Okay. We're going to here. Left is what? Okay, so left is now n plus 1, which is 3, right? So 3. So 3 plus, what is this again? Let's see, 1. So 5. 3 plus 5 divided by 2. 3 plus 5 divided by 2. That's 8. 8 divided by 2 is 4. Yeah. 4, right? So that is here. So this is the middle. Yeah, fine. If target is equals to that, no. If target is 1, so no. No, it is this, so we're going to return that here. Okay. So at least that works. But this one, um, let's try this other example. Let's see, 350162, okay. Um, okay, so we're gonna check, is it rotated? Yes, it is. Okay, so, okay, numbers M, so this is 6, right? 0, 1, 2, 3, 4, 5. Yeah, so, yeah, 5, 0, 2, 2.5, 2, so here, 1, 2, so 6 is the midpoint. Um, okay, okay, then if 6 is greater than or equals to 0, so yes, it is. Um, okay, nice. What happens if it isn't? Part of me feels like this is tautology. No, it's not. Or we could actually just, yeah, because low key, it feels like I'm doing this epic. So why don't I just bring this out here? That might be more efficient. Because I'm doing the exact same thing else in there, yeah. Um, hi, hello, Shy 5G. How are you doing? Um, give me 1 second. Well, let me also check what is my Twitch saying. To be, bro, bro, it's real, bro. It's rough in these streets, bro. It's rough in these streets. Oh my. Yeah, I need to find a way. This probably wait. Well, let me solve this question first and then we go on. Okay, yeah, cool. Let's go to -1 here. Cool. So we are okay, 6 we okay, that's 6 with the middle. If it's greater than that, yes it is. Okay, so target is gonna be because of this, and then left is gonna be here, down. Okay, cool. If target this. No, so I mean we're already left here. Okay, so while left is okay, let's let me do this. We're checking. We didn't find it. So but a part of me feels like this is wrong because if 4 was to be here, 4 would be in this part and not that part. So but let's just run it. Look at talking too much. Okay, so it passed with both of them, obviously because I dry run them, but it's probably gonna fail somewhere. Yeah. Oh, okay. Only missed 10 cases. I was looking for 3. Oh, we got -1. 351. Okay. Yeah, let me run through my case to see why it didn't work. Um, thank you, man. Thank you. Uh, well, okay. Maybe, obviously the midpoint is gonna be 5. It's 0, 2, 0, 2, 0, 2 is 1. Yes, and the midpoint is gonna be 5. Yeah, that's cool. Okay, and that, yes, because it is rotated. Okay, once M is greater than or equals to this. Yes, it is. Yes, so the target is less than or equals to target equals to is target less than? Okay. Yes. So it should have been in the other case, which is why I don't. There's a glitch somewhere, and it's like because you would think because obviously, right? You would think yeah, something less than that, and you want to make it the other way around, but then that's gonna fail a lot of cases. For example, I get this, right? This is logically what it's supposed to look like, but it's gonna fail. Yes, right? Because of this one, it's gonna pass that one for sure. But that's because it's minus one. You know what I mean? In this case, it's really four. So let me do something. Let me see how much it fills with this. It doesn't even get any of those. Nice. So there's something that I'm missing. And I obviously don't want to do the jailbreak where, okay, if it's the first thing, yeah, 'cause I know. But that's not going to help with the algorithm. How much time do I put? I think I'll let you pass the time that I want to do. But I want to get it. Um, how much did I spend? 47 a.m. The thing is, I'm so close, but I don't know why. I don't know what the issue is. Yes, everything behind it is less. Which logically, yes, it does make sense, right? Because as I said that, but we also need to, and the only way we would have done that is if, but then obviously max, like if you do, so if you do max, right, it's going to be O of n, right? It's O of n, exactly, right? So that's not even going to help because it's being stuff. So, because the only way that would have worked is if it was that. But the thing is, I can't just use some models. I don't know why I can just use regular logic because I don't want to look at the solution because I know I can get this. It will take some time, but I'm going to get this. Mm, Okay, I think logically it does make sense to search there first. And if it's not there, then it has to be the other one. All right. But then technically you're not. Then there's no point of binary search because you're not determinate, right? Like yes, I understand that. Like yes, if you're looking for, you know what I mean. Hey man, Jets, how you doing? I'm doing good. How about you? Mhm. Let's do this first. So that we could go into, try again. Um, so that is guaranteed. That doesn't, that's gonna happen irrespective, right? So now let's think, okay. So we have things out. Okay, okay. So it's 351, right? So we have 351, right? So we've identified that it is a rotated list, right? And we know that this is the middle number, right? And we have a target of 3. If I were to get to 3, first of all, I think the context is I need to know if the thing at the middle is the pivots, which I technically can check. Thank you, man. I appreciate it, man. Thank you so much. Which I technically can check if the thing at the middle and the thing right next to it, if it's greater than that, then it's the pivots, right? Okay, that could be. So I could do, okay, if nums m is greater than nums m plus 1, and we're guaranteed that nums m is not there, right? Unless it's, yeah. Yeah, we can have a check for that. Nums m plus 1. Then we know it's the pivot. So if it's the pivots, then anything, so we could actually either be at the left or the right, right? That's if it's the pivot, right? Cool. So if it's not the pivots, then technically everything behind it has to be lesser than it, right? Yes, but in this case, it is the pivot, right? So, and it has rotated. Yeah, it does, man. I'm trying to explain it to myself. Um, so it is the pivot, right? So we can also check, okay. Oh, I had something there, but I lost it. Okay. So it's the pivot. If it's the pivots, then technically the answer could be at the left or the right, right? But we then need to know, um, and in this case, target is 3, right? So, but this is very definitive. Okay, I want to see another example where it uses. So, for example, 3, 4, 5, 6, 1, 2. So we got 3, 4, 5, 6, 1, 2. Right? Cool, right? So let's So we know the midpoint is, wait, so this is 0, 1, 2, 3, 4, 5. 5 divided by 2 is 2.5. So 2, so 0, 1, 2. So this is the midpoint here. Fine, right? Okay, then we now check, is this the pivot? No, it's not, because 6 is the pivot, right? And how we would check that is if nums m is greater than nums m plus 1. Yeah, you know what I mean. Yeah. So if it is, then it's the pivot, right? Fine, identified that, right? So it's not, yeah, it is. If it is, yeah. So in this case, it's not the pivot, right? And let's say, what is the target? The target is that we're looking for 1, right? Target is equals to 1, right? So in this scenario, what do I do? In this scenario, target is still less than that, right? So the educated guess is to do, the educated guess is to still go use the left part first, right? But if it's not in the left part, then we go to the right part. Okay. Which in reality, you're technically going, that's technically over because you know what I mean? So you're not even solving any more the time because there's no actual indicator to tell you if one is in there or not. Because genuinely one is less than 5, right? And we have identified that it is rotated, right? I guess you could use context of the number and the index that it is currently at. Right. So for example, if okay, we're like 5, right? And if 5 is not at 4, that's too much, man. That's too much. Okay, wait, let me try. Okay, 5 is not at 4, then technically obviously it's rotated. We know that, right? That's like another way to check if it's rotated or not. That's fine, right? But then that's not really gonna help you to find exactly where one is at. Wait, that might have been because the answer is 4, right? That could be a trick. That might just be a trick. Give me 1 second. Let me do 350 3, 5, 0, 1, 2. Right. So the midpoint is what? So 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5. So that's 2.5. So 2, 3, 1, 2. So this is the midpoint here. And what is the target that we're looking for? The target that we're looking for is 4, right? So technically, the midpoint originally should be at 5. Then we check out at position 5. If the thing that we're looking for is not at 5, no, but that doesn't make sense, right? So for example, in this setting, was to do that, right? So this should be at what, 4? And what is that for? I feel like that was just luck. I don't think that's correct. Let me try it again for. Let me do. I think I might be onto something. I want to check something. So if I did, let's say 7, 6, so 7, 8, 1, 2, 3, 5, 6, right? So using that logic, right? So 0, 1, 2, 3, 4, 5, 6, 7. So 7 divided by 2, that's what's that's 3.5, so 3. So 0, 1, 0, 1, so 3. So this is the midpoint here, right? Cool, right? So on a normal day, right, the midpoint is 2. 2 should be at 2, position 2, right? Because it's not 0. I'm guessing it's not. The numbers I've seen, the constraint is, it could be 0. It could be 0. This shit is annoying. Okay, we'll see. Yeah, sure, why not? Um, 2 is at position what? 4. So the target is, oh, what is my target? C, I don't know. Let's use 351. Let's use 351. Yeah. Oh, maybe it was 5. Okay. Technically, this should be at, oh, but then I'm assuming it's always numbers that are, you know what I mean? Yeah, so that logic does not work. Mhm. Mhm. Yeah, thank you, man. I appreciate it. Good luck for your exams, man. This is not a hard question. I don't know why the fuck I'm getting frustrated about this shit. um, okay, I just thought of something. If it's rotated and it's not the and it's at the pivots, we can check what the first element is. If if the target is already smaller than the first element, then it has to be on that side. Okay, wait, I just caught something. Okay, so if it's rotated, if it's rotated, if it's rotated and it's smaller than the first element, then it has to be on the right. Okay, so if it is rotated If you rotate it and it is smaller than target is smaller than what do you call it? So if target is oh I didn't see. I didn't see this. I know what they're talking about. It's all good. Okay. Okay, what was it again? If target is smaller than at its start, or if target is smaller than 0, then it has to be everything after that. That makes more sense. Then so the target is lesser than the thing at the start, then it's everything after the midpoint. So it's gonna be equals to m plus 1. Realistically, yes. Um yeah, exactly, right? Yeah. If not, then if not, is it guaranteed? So for example, if yes, technically it's guaranteed to be everything, yeah. So else um I think this is more accurate. Because if you really think about it, right? If it's not the if it's not the midpoint itself, fine. If it's the midpoint itself, we get the answer automatically. If it's not the midpoint, then we check if the target is smaller than this here. If it's smaller than this here, then it's guaranteed that it has been rotated, so it has to be everything from here to this. If not, then so for example, if the target was like 4, then it has to be between this and that. Yeah. And then you perform binary search on it. Let's try. There we go. Oh my goodness. Also close. Okay, wait. So okay, 513, 35. Okay. At least we're getting closer for sure. 513, 35. Opposed minus 1 is going to be 0. Why didn't this work? Target is 5. I did that, right? No, this is supposed to work. But give me one. What? It is rotate. Is it rotated? If no 0 is greater than yes, it is rotated. Yeah, okay. So if num_m is greater than that's 0, okay. Num_m is greater than that. What did we get? Num_m is greater than this. No, it's not. Is it greater? No, it's not. Okay. So then target. Okay, so what it's gonna be? Okay. So 0, 2 is 1. Okay, mid is 1. The target is less than. What do you think the target is? That should be else. Oh, I see what you mean. Okay, yeah, so we need an else case for this. Else you want to so if this is not there than that, I don't know what that means. Let's see. So it's not greater than that, then if it's not greater than that, you know what I mean? So there's an edge case where uh, then it kind of has to be between behind that, right? Yeah, so let's see, try this one. Let's just try this out. Let's see this. Okay, you lost something. Okay, thank you. Oh, you're right. Yeah. Yeah. Yeah, this is to tell you the target does matter. So it's a good indicator to tell you that necessarily the target's in here. Else, it literally could be anywhere. That's the thing. This case is the one that's killing me because it could be left or right. Right. I need you to understand what's going on. You know, oh man, if it's not, then what does that mean? Oh wait, okay, wait. Actually, oh yeah, 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 yeah. Because I was like, I mean, you can see my face. Okay. You guys have really seen how I think here. Oh, I'll tell you. Um, something. Over one started up mhm. This logic really does help. Also, yeah. But then it's tautology at that point because then there's no point of doing that, right? So are you trying to say that this doesn't make sense? Let me take this off. Yeah. Okay. Okay, yeah, okay, we're getting better. Okay. There's three more test cases. The thing is, Mr. Andrea, the thing is, this is not a hard question. This is really not a hard question. It's actually just a combination of binary search, but like in a different format where you have to deal with rotations. But the rotation is like the context of it is understanding where you are, what the pivot is, and how to find the fastest way to find it. Obviously, you can do the brute force where you're like, okay, if it's not here, you go here, right? But that's all and instead of all again, right? So I'm really trying to, but I believe the solution is actually really easy. I don't think it's hard. I really don't think it's hard. I just want to really understand what's going on before okay, so it rotated early here. So target is equals to 1 here. Um, so midpoint will be what? It's 5. That's a geez, I don't know. So 4, so 2, so 1, 2. So this is the midpoint here. Okay, the midpoint is here. Here. So if inverse 2. So and that's it. Okay, if target is less than or equals to 0, that's where the logic is. Okay, that's where the mistake was. Here. Yeah, target is but I don't agree with that. Well, in this scenario, that doesn't work right here. Oh well, yeah, yeah, because I didn't put them. So we just need to check somewhere. We need to blur it here. And I'm so close, bro. Just three more test cases and we're good. Yeah, if I don't get this in the next 10 minutes, then I'm gonna look at the answer. But this isn't supposed to take this long. That's the another thing. It's yeah, right. Yeah, mine is like it's not even just the edge case right now. It's more or less like I'm so close. Like obviously, I can go to VS Code debug and figure out why it's giving that. I understand that, right? But I wouldn't be able to do that in like well, it depends on the company. I might not. Some companies will just give you like what do you call it? Like a Word document to what do you call it to coding. So it's not like you know what I mean. So it's not really realistic for me to go to VS Code and debugging right now because I don't think I'll be able to do that in every single scenario. So why not just prep for the worst, right? Um, the reason why I'm so adamant on it is because I am three test cases away from getting the whole thing, and that's why I'm like I'm gonna find this answer. I don't care because logically, what I was going with this code block is okay. If you have obviously to check if it's rotated is if at some points if the thing at the start is greater than the thing at the last point, right? That means that's been modified because the list is intended to be in ascending order. Fine, right? So if this condition is satisfied, then it has been rotated. Fine, right? So first we're just gonna check, okay, the thing at the middle, is it the answer? No, it's not. Okay. If it's not, then the thing we're looking for if is it smaller than is this smaller than the thing at the start? Yes, it is. So that means for sure it's everything after that. I think I should make it like instead of everything. Let me do this. And just say let's equals to one. Let's do this first. Yeah. I wonder why that didn't work. Or when L was equals to one. Because if L is equals to one, right? Then okay, we have one plus, the end of the list. We have the whole list essentially, right? So target is greater than or equals to that. So calculate the midpoint again. Midpoint is going to be, we can use this. So the midpoint's going to be what's, let me just submit this. Let me see how much this actually gets. Sorry, not this. It doesn't even get me shit. Mm. Okay, let me see this. This is not the problem at all. It's this logic is the problem. because technically, if you look at it right, if the pivot is at the start, then it's everything after the pivot that should be the answer. At least the answer should be at that, right? So I'm wondering why it's failing. Like I can understand you in this scenario, yes, obviously, I have this too. You know, it doesn't know what to do, right? So obviously, yeah, they're searching for this. Obviously, it's not in there, so it's going to return -1. I get that, right? But in this case, right, I get that, right? I get that. It's weird. How? How? That's why I thought, how? How is this wrong? What the fuck? Like, you know what I mean? So target is equal to 1, right? Okay, fine. So the target is less than 0. Yes, it is. Target is also less than m. Oh, I see. Yeah, right. So, yeah. So, it doesn't necessarily mean that. Yes, I get that. So, why is it that in this case, where, like, obviously passes for this, yes, but in this case, I'm 30 off. Never know. I'll give myself 10 extra minutes. That's why I don't like this. It's like fam, that's not what I'm looking for. Okay. So it works for that case, but it doesn't work for this. Why? Because now I'm just searching the whole freaking thing. Why is that 3? Why is it 3? What the fuck? How did we get the 3? The target is not. What are we doing? Yeah, so why is it triggering this? Okay. Why is L5? Oh, sorry, no. N is 5. Why is it 5? Target is 1. L is 9. R is. Because there's 6 numbers up there. Yeah, so yeah, so All right, let's look at the solution then.
Okay, let's solve LeetCode 33 sharpen rotated sorted array. So we're basically given an array that was originally sorted like this one, but then it became rotated like this one. And by rotated, they mean that they took a certain pivot or index of the array, like right over here, and then they cut it in half and then swapped the portions, right? So you can basically think of this right-hand portion being swapped over to the left side over here, right? That's what happened as position. And we're also given a target value, in this example, target 0, and we want to check if our array contains this value. If it does, we return the index. If it doesn't, we return -1. The most straightforward way to approach this problem is literally just check every single value. Is this our target? Is this our target? And eventually we'd get here, this is our target. And then we return the index 4. Now this is just too trivial of a solution, right? The time complexity isn't bad, it's O of n, but can we do better? In this problem, they literally tell us to find a solution that's O of log n, so obviously we can. And basically, anytime you're looking for a solution that's log n or better than linear, almost every time you're going to be looking for a binary search type solution. So since this array was originally rotated, can we use that to our advantage to potentially find a binary search type solution for this problem? Let's try to analyze it and see what we can find. So given that the original array was sorted, if we wanted to represent that as a graph, we would basically have a continuously increasing line. It might not necessarily be linear, but it would always be increasing, right? And then we took some pivot, like over here, and then swapped these halves around, right? So let's draw what that would look like. So let's say the left side was exclusively greater than the right side, because that's what it means by rotating the array, right? So I think this is a pretty good way to visualize a problem to kind of understand what it would look like. And you can use this to your advantage to find potential patterns that can help us find a binary search solution. So with a problem like this, you really have to break it down into discrete cases and then use those cases to form a solution. So the most obvious thing is that there are two portions of the array, right? There's a left portion and a right portion. Both independently are sorted, right? So it's like we have two halves that are sorted. And so we know that a binary search usually has 3 pointers, a left pointer, a middle pointer, and a right pointer. The left is always going to be less than or equal to the right. This is just something you kind of know from binary search. So let's say our middle value was 6 at some point, right? This means that we're in the left sorted portion of the array. So can we use that to our advantage? So let's say our target was greater than 6. In that case, we know for sure, since we're in the left sorted portion of the array, none of these values are greater than 6. So we can basically say these are eliminated. Let's run binary search on this portion now, right? So that's pretty easy. If we know that we're in the left sorted portion and our target is greater than the middle, this is what we can do. What if our target is less than the middle value? So what if our target was less than 6? Well, these two numbers are less than 6, and these 3 numbers are less than 6. So how do we know which way to go? Do we go left or do we go right? Because we can't go both directions in a binary search. The key is to see that in our left sorted portion, the smallest value is right here, right? We're on our graph, it's right here. So if our target is even smaller than this left value, 4, in that case, we know that we don't have to search 4, we don't have to search 5, we don't have to search 6. We don't have to search 6. Exactly what I'm doing here. But if our value is greater than or equal to 4, then that means we're going to run binary search on these two values, right? It's less than 6, but it's greater than or equal to 4. So we can run binary search on these two values. We can eliminate all of these from consideration. So all of that is if we were in the left sorted portion of the array, right? Now what happens if we're in the right sorted portion of the array? Let's say our middle was 1. And let's say we knew somehow that we were in the right sorted portion of the array. What if our target was less than 1? Well, then we know we have to search the left. The only value less than 1 is right here. So we're going to search the left portion of this array. We're not going to look at 1. We're not going to look at 2 anymore. Any value to the right of 1 is greater than 1, so we don't have to look at them. We're just going to run binary search on these elements. We don't necessarily have to know where the pivot even is. We just know we have to go left. But what if our target was greater than 1? Well, then our solution could possibly be 2. It could also be any of these 4 values. So then where do we go? Again, we can use this rightmost value, or the edge basically of our array, to our advantage. So if our target is greater than 1 and it's also greater than 2, that means we can again search this left portion. We can eliminate these two from consideration. But what if the opposite is true? What if our target is greater than 1, but it's less than or equal to 2? In that case, we only have to run binary search on the right portion of 1, every value to the right of 1, meaning we can eliminate all of these from consideration. So that was a lot of discrete cases, and it might be confusing. I think it'll be a little easier to understand once we actually write the code, but I think it's also important to visualize it and actually understand what's going on before you even write a single line of code. And knowing what we just learned, let's just go through this example of the target equal to 0 and given this input array. So initially, our left pointer would be here, our right pointer would be here, our middle would be here. So how do we even know if we're in the left sorted portion or the right sorted portion? Well, the way I check is just if our middle value is greater than or equal to our left, the actual value at that index, if this is true, then that means our middle value belongs to the left sorted portion. If this wasn't true, that means our middle value is in the right sorted portion and we would write our if statements accordingly. But knowing that we are in this left sorted portion, right, let's run through it. So our target is 0. That means our target is less than 7. So our target is less than 7. That means we could be looking here or we could be looking here. So let's compare it to 4 now. Is our the left sorted portion or the right sorted portion? Well, the way I check is just if our middle value is greater than or equal to our left, the actual value at that index, if this is true, then that means our middle value belongs to the left sorted portion. If this wasn't true, that means our middle value is in the right sorted portion and we would write our if statements accordingly. But knowing that we are in this left sorted portion, right, let's run through it. So our target is 0. That means our target is less than 7. So our target is less than 7. That means we could be looking here or we could be looking here. So let's compare it to 4 now. Is our target less than the leftmost value? Well, 0 is less than 4. Okay, so that means we're all good. We just have to search every value to the right of our middle value. So we can eliminate all of these. We can cross out our middle and left. Our new left is going to be here, and our new middle is going to be here. Now in this case, are we in the left sorted portion or the right sorted portion? Well, among these three values, the entire array is pretty much sorted. So according to our if statements, we're basically going to say that middle belongs to the left sorted portion because the entire thing here. 0 is less than 4. Okay, so that means we're all good. We just have to search every value to the right of our middle value. So we can eliminate all of these. We can cross out our middle and left. Our new left is going to be here, and our new middle is going to be here. Now in this case, are we in the left sorted? According to our entire, we don't have to left with a visual. Okay, so when you're doing by 0, the middle value is greater than the left value. Well, greater than or equal, right? Because it's possible that the middle value and the left value could be the same value. The else condition would be that we're in the right sorted portion. So the simplest case is that our target is greater than the middle value. In that case, we're going to search right. So we can say our left and say, so we can type in mid minus 1. So if this isn't true, meaning target is greater than middle, left, our new left is going to be here, and our new middle is going to be here. Now in this case, are we in the left sorted portion or the right sorted portion? Well, among these three values, the entire array is pretty much sorted. So according to our if statements, we're basically going to say that middle belongs to the left sorted portion because the entire thing is sorted. So now we compare middle to target. Well, our target is less than 1, so now we have to go left. And if we compared it to the leftmost value 0, our target is greater than or equal to that. So we don't have to check anywhere else, we only have to go left. So we can eliminate these two from consideration, and we're left with one value over here, and that's our solution. So this is kind of a visualization for it. Now let's actually look at the code to better understand what these cases are going to look like. Okay, so when you're doing binary search, first thing you do is initialize your pointer. So we have a left and we have a right. Left is going to be 0, right is going to be left value could be the same value. The else condition would be that we're in the right sorted portion. So the simplest case is that our target is greater than the middle value. In that case, we're going to search right. So we can say our left pointer is now going to be mid plus 1. So if the target is actually less than the middle, then we need to do something else. So if the target is less than the middle, but it's also less than the leftmost value in nums, then we also have to search the right portion. So we're going to do left is mid plus 1. Now notice how these two cases are evaluating to the same thing. That means we can condense them. We can get rid of this and say instead if the target is greater than the middle, or if the target is less than the leftmost value. Then we have to search the right portion, so we can get rid of this. And if isn't true, meaning target is
Do I have any advice for data analyst jobs? I'm not a data analyst, so I don't really have the best advice. I will say, just learn as much as you can in regards to SQL. Um, like, and not just the basic, select statements, like learn window functions, learn CTEs, learn how to clean data, like, and understand the whole ETL pipeline for sure. And then once you're confident in doing that, you can start then tackling projects and like make it stuff that's like either trending or fun. That way at least you're putting yourself out there for employers. Um, and reach out to people that you admire in the field for advice. Because again, I'm not the best data analyst, or I no, but that'll just be my advice. Yeah.
greater than middle, and the target is greater than the rightmost value, that means we have to go left as well. So right equals mid minus 1. Notice again how these two are doing the exact same thing, so we can condense them. We can say at the top if the target is less than the middle, or if target is greater than the rightmost value, then we're going to search the left portion, so we update our right pointer, so we get rid of this. And the else condition is that the target is greater than the middle value and the target is less than the right value. In that case, we only have to search the right portion of the array. So we update our left pointer to mid plus 1. These are all of the cases, right? So if we find our result, we're going to return it up here. But if we don't find it, we'll exit the loop and we'll return -1. And just as I
We did this really fast before. Yeah, that's pretty much it. Taking how long? 2 hours. Yikes. But that's the stream, guys. Thank you for watching. Bye bye.